Hello, I'm KM, an associate professor in the School of Life Sciences, Chinese University. Here in this video is the second one for 3 videos on pesticides and trace organics for biochemistry and public health. In this video, we look into trace organics, their receptors, toxic effects, and risk assessment. They are called trace organics as they exist in trace amount, could be halogenated, persistent, and toxic at very low concentrations. Initially, we studied fossil fuels and tobacco smoke, found a representative compound called benzoate-pyrene. It undergone phase 1 and phase 2 metabolism and become activated to form DNA adducts, leading to gene mutation to cause cancer. Polychlorinated dibenzoyl P-dioxins, PCDDs, polychlorinated bibenzofurans, PCDFs, and polychlorinated biphenyls, PCBs, are chemically classified as halogenated polychlorinated aromatic hydrocarbon, or PHAH, planar halogenated aromatic hydrocarbons. Dioxins have 2 oxygens linking the 6 carbon benzene rings. Furans have 1 oxygen, and biphenyls have no oxygen linking the 2 rings. They have different numbers or amounts of chlorines or halogens linked to the phenyl or benzene rings, making up to many different congeners. There are other similar chemicals like benzoate-pyrene used as a standard or representing chemicals. Dioxins are a group of chemicals humans ever made or created as highly toxic and persistent, even at very low concentration. There are 75 congeners, including the most toxic one called TCDD, 2,3-7 tetrachlorodibenzoyl P-dioxin. The US EPA drinking water limit is set as 0.00003 milligram per liter, or ppm. That is 0.03 ppb, or 30 ppt parts per trillion. 50 ppt in seafood, 45 or lower to 4 or 5 ppt in air, even less as 0.5 ppt for wastewater. The US daily intake is estimated to be 20 times 10 minus 12 gram per kilogram body weight. The WHO data of tolerable daily intake is set as 1 to 4 picogram (pg) per kilogram body weight per day. Dioxins have 2 oxygen linking 2 benzene ring up with different numbers of chlorines joining the carbons on the rings, showing a possible total number of 75 congeners. 2,3-7 tetrachlorodibenzoyl P-dioxin 2,3-7 TCDD is the most toxic one among all congeners, with 4 combinations at the corners. Main characteristics of dioxins include their low vapor pressure and water solubility. In other words, they are highly lipid soluble, persistent, and chemically stable that could be bioaccumulated in lipid as they are highly lipophilic. They have very long lifetime of decades in human. The Southeast Asian country victims nowadays are still suffering from the Agent Orange health outcomes from using TCDD in Vietnam War back to 1970s. TCDD and dioxin-like compounds all can bind to a protein receptor found in animal tissues called AHR, aryl hydrocarbon receptor. The mechanism of intracellular actions of dioxins and dioxin-like compound is drawn in this diagram, with the chemicals entering the cell via diffusion through the cell membrane, because the membrane is a lipid bilayer and these chemicals are highly lipophilic. They are found to be associated or bound with HR, which originally attached with heat shock protein 90 and other protein factors binding before binding to dioxins. Once bound to HR, they get on to a partner called ARNT, HR nuclear translocator, to enter the nucleus to turn on genes known as the phase 1 and 2 enzymes. Here exemplified as CYP1A gene or cytochrome P451A gene. The enzyme is produced and undergoes and goes to the endoplasmic reticulum to further metabolize dioxins and dioxin-like compounds. What compounds have similar mechanisms of actions? Dioxins, furans, benzoate-pyrene, with more rings than other compound called methylcoanthine, a less toxic and model compound used for testing. Since HR is found, or this mechanism of CYP1A gene induction is found in almost all animal species, even before human beings started to make TCDD in recent decades. This raised a good question to ask is, what are the endogenous ligands for HR? It is believed that the endogenous compounds are indole carbazole compounds found in many plants and diets for animals. Hence, the HR-ARNT pathway of CYP1A induction for drug metabolism is for animal species to handle incoming chemical insults. We now turn to the questions on the toxic effects of dioxins and their risk. Coronate or chlorate is the most common defect found in patients suffering from the intoxication of Agent Orange in Vietnam. Both PCBs and dioxins cause coronate, probably caused by the halogens in the chemicals. From animal studies, the coronate is actually dilation of the infundibular or suprafollicular area of hair follicle with hyperkeratinization. That is the accumulation of keratin and sebaceous gland secretion on the skin. Coronate is an occupational dermatosis with numerous acne form lesions located on the face and neck behind the ear. The cross-section of such follicular hyperkeratosis in mouse skin treated with tetrachlorophenol biphenyl, showing the thickness of the lesions. One tragic example is the Ukraine president, Viktor Yushchenko, who was poisoned with a spoonful of dioxin-like substance. Look at his face before, during, and after treatment. Today, dioxins and dioxin-like compounds are proven carcinogens, showing birth defects, causing malices, endocrine disruption, and reduction of immunity in victims with metabolic diseases. So these compounds are so dangerous. How could we study their potential risk? We use the concept of toxic equivalency factor, TEF. Since dioxins and dioxin-like compounds exist everywhere as complex mixture of congeners, we have a comparative toxicology approach to study all of them together as mixture as they all bind to HR. This is simply for risk assessment and regulatory control. We set the TEF of TCDD2378 as 1, as it is the most toxic compound and has the highest affinity with HR. Combining PCBs and dioxin-like compounds in one formula, we can calculate the TEQ or toxic equivalency quotient. And the WHO recommended standard is 4 × 10⁻12 gram TEQ per kilogram body weight, or 4 picogram TEQ per kg body weight. Here is the formula we have. TEQ is a summation of each dioxins, furans, or PCB with their concentrations times the TEF. The criteria set for the chemicals to be included as they have similar structures to dioxins and furans, bind to AHR, elicit AHR-mediated gene expression, and persistent and accumulable in food chains. For examples, this table lists the TEF values for dibenzo-P-dioxin and dibenzofurans. 2378-TCDD is 1, 2378-TCDF is 0.1, and so on. Some may have higher TEF values, but the concentrations could be low, and vice versa. Adding them together, we can estimate or calculate the TEQ values from different food types, such as cereals and meat, with their daily consumption in kilogram per day, and TEQ values determined to estimate the daily dioxin intake. Say here it's 5.3 picogram TEQ for cereals and 22 picogram TEQ for meat. Here's a table showing the calculated PCDF levels in general population a few decades ago, with blood samples and breast milk samples as dioxin and furans are lipid soluble in Germany and the US. Various chemicals determined, calculated with the TEF values, adding up to the TEQ as 43 or 42 picogram TEQ in blood or 18 picogram TEQ in milk per kg weight. Some chemicals like TCDD has lower concentration but higher TEF, lower TEF but higher concentration as for OCDD. This table with the estimated dietary intake of PCDDs and PCDFs in the UK with food analysis of daily consumption, dioxin concentrations in TEQ, looking those in red with high daily intakes from meat, eggs, and milk, all lipid-rich materials on our dining table. The total dioxin uptake calculated as 125 picogram TEQ per day. Similar studies for Canadians, also mainly from beef, eggs, and milk, a total of 91.7 picogram TEQ per person. As if you assume the body weight on average is 60 kilogram, rounding up the figures, you could come up with the number of 1.52 picogram TEQ per kilogram body weight per day of dioxins and dioxin-like compound intake, below the 4 picogram TEQ per kg per day. Remember the WHO standard is set as 4 or 1 to 4 picogram TEQ per kilogram per day. The data of 1.52 for the Canadian is acceptable. However, such TEF concepts or scheme for estimating these mixtures of chemicals remain the most feasible approach for risk assessment, despite of the fact that we use mouse HR to do the calculation of TEFs. The additives or non-additive interactions of these chemicals remain unknown. Actually, what chemicals could be included? We now also include some PCBs for the calculations of TEQ values of dioxin and dioxin-like compounds. The first dire study of dioxin risk for Hong Kongers is summarized in this table. Comparing with data from other countries, the average value is 21.92 picogram TEQ per kg body weight per month. That is less than 1 picogram TEQ per kg per day, but the high consumers had 59.95 picogram TEQ per kg per month for 95 percentile, that is around 2 picogram TEQ per kg per day. We're still within the 1 to 4 picogram TEQ kg per day, but obviously we could do better as the data from Australia and the US are lower. Finally, in the next few slides, we look at PCBs, which are also included in the calculations of TEQ for dioxin and dioxin-like compounds. Some PCBs are also AHR agonists. with much lower TEF except PCB 126, that is 3 pi, 4 pi 5 penta CB is 0.1, and PCB 169, 3 pi 4 pi 5 pi hexa CB is 0.01. They induce CYP enzymes 2A1 and 2B1. They enter the cell freely to alter calcium ion signaling in lymphocytes, neurons, and muscle. They produce immunomodulatory effects and the development of cardiovascular disease. There are also endocrine disruptors. Some are estrogenic and some are anti-estrogenic. This table summarizes the TEF values for various PCBs. PCB 126, 169 have higher TEF values of 0.1 and 0.01 relative to TCDD, which is 1. Last but not least, PCB intoxications have been reported in Taiwan and several European countries, including Italy. Here, this case is called U-chain or oil syndrome in Taiwan. In 1979, cooking oil was replaced with engine oil used in making rice cake, and the whole incident lasts for 9 months, with some victims consumed close to 1 gram of PCB chemicals. 1,991 victims, with 70 children exposed in utero from their mothers, were traced over a few decades. The most get coronary and hyperkeratosis, with higher mortality that were mostly in males with malignant neoplasm, digestive tract problems, and lupus erythematosus after 30 years from the 1979 accident. I hope that we have learned about dioxin and dioxin-like compounds because they act on AHR together with some PCBs. We study them as mixture with the concept of TEF and TEQ to estimate their risk posed on our health. Bye-bye.